What is sliplining? Sliplining is a trenchless rehabilitation method in which a new, smaller diameter pipe, called the liner, is inserted into an existing damaged or deteriorated pipe to create a new flow line. The existing pipe remains in place while the liner is joined by fusion or gaskets, pulled or pushed into position, and then tied into the system at access points such as manholes. The gap between the old pipe and the liner, when required, can be filled with grout, and the completed installation is tested to ensure performance. Why choose sliplining? It restores hydraulic capacity and reduces infiltration and inflow without the disruption and expense of full open cut replacement. For projects where surface disruption, traffic impacts, or restoration costs would be significant, sliplining is often the more efficient, less intrusive option. It extends the life of existing sewer infrastructure while minimizing impacts to the surrounding community. When is sliplining used? It depends on the condition of the existing pipe and project goals. It is suitable when the host pipe is essentially continuous and structurally sound enough to accept a liner, but requires leak mitigation, flow restoration, or corrosion protection. It is also chosen when obstructions or limited defects can be corrected with local point repairs prior to lining. Conversely, sliplining is not appropriate when the host pipe has large, irreparable sections, or when a proving manual or pre-check indicates the liner cannot be passed. Those sections must be excavated and replaced before sliplining can proceed. Where sliplining is used? Most commonly in gravity sanitary sewer runs, where access points allow insertion and reconnection. For larger diameters, it is common practice to grout the annular space between the old pipe and the liner to provide structural support and reduce water migration. For manhole interfaces, special sealing and transition work is required so the flow line remains smooth and watertight at the connection points. How is sliplining installed? The process begins with cleaning the hose pipe and conducting a post-cleaning CCTV inspection. The hose pipe is also checked for structural stability, ensuring there are no collapses or severe deformations that would prevent liner installation. In many cases, a clearance check is done using a caliper pig, proving piece, or a short trial liner section to verify the liner can pass through without issue. If access is limited, launch and receiving pits are prepared to allow the liner to be installed. During sliplining, the liner pipe sections are introduced into the hose pipe. In large diameter work, the liner is often fused into long strings of HDPE or other suitable material, and then pulled or pushed into position with winches or similar equipment. Once the liner is in place, the annular space between the host and liner pipe is grouted. This grout supports the liner, prevents voids, and ensures long-term stability. Grouting is usually staged to control pressure and avoid deforming the liner. Throughout this stage, the crew monitors alignment, grade, and grout pressures to ensure the installation proceeds safely and correctly. After installation, the liner and joints are tested, commonly with low-pressure air or other accepted tests, and any deficiencies are repaired and retested until the installation meets acceptance criteria. What is the liner made of? Liner material and jointing are prepared per manufacturer instructions. For example, HDPE is typically butt fused above ground and protected during insertion. FRP or centrifugally cast liners are jointed and handled following the producer's procedures. Continuous assembled pulls are planned within practical length limits, and pulling or jacking forces are monitored so they never exceed the manufacturer's recommendations. Tension gauges or similar devices are used to verify pulling forces and avoid buckling or damage. Good planning and quality control are essential. Protect liners from damage during handling and storage. Verify all joints and fusion work per procedure. Measure pulling forces throughout the pull, and ensure manhole transitions are properly finished. At the end of the day, sliplining is a reliable, cost-effective method to rehabilitate sewer pipelines with minimal surface disruption.